Hi, hello students. Welcome to LTX classes. This is me, SPR. Today I'm gonna present you geography concepts. So, in this session of geography concepts, I'm gonna discuss about a topic called shadow zone. So, I'm gonna discuss about shadow zone. What is a shadow zone? How it is very important. Everything I will be dealing for your exam perspective. So this geography concepts is part of UPSC preparations. Part of UPSC, it is mostly concentrated on the prelims and mains oriented approach. So if you are preparing for UPSC, then this channel will stand as a best platform for your education journey. So this will help you in understanding the concept and learn more accurately. I had provided a previous topics related to, that is, seismic waves and whatever related to this topic. If you view the concepts and come over to this topic, this will be very easy for your understanding. First of all, let me tell you what is a shadow zone. Shadow zone means it is related to seismic waves. Seismic waves means we had understood that is earth wave. So that is created along the earth. So seismic waves. So these seismic waves are to be in some places. So when seismic waves are traveling along the interior of the earth at certain places only, some places, so few places, the seismic waves are to be unable to detect. So we are unable to detect them, which means these seismic waves are shadowed. So they are shadowed at some regions. So this is unable to detect in seismographs. We know that seismic waves are to be calculated in the seismographs that are being unable to detect in that region. So that is what called as shadow zone. So before understanding the shadow zone, I will explain you few things, which means property of a few waves that is necessary for your understanding to learn about shadow waves. So if anyone asks you about shadow waves, simple answer is seismic waves are unable to detected and in seismograms at certain places, that is a shadow zone. That is what a perfect definitions we can write it for it. Now before that, you must know the characteristics of the S waves. So we know that S waves, so it does not pass through. So S waves passes only through solids. So it doesn't. So we know that S waves doesn't pass through. So they are unable to pass through, which means they are not detected in liquids. So they are unable to pass through liquids and gases. So this is what we know, that this is a feature of S waves, which means they travel. So S waves travel only through, so they travel only through solids. So this is what a property of the S waves. And next, P waves. So we know the property of a P waves, which means P waves passes through all the mediums. So P waves passes through all the mediums, which means they can pass through solids and also liquids. Okay, all mediums. This is what a property or quality of the so-called P waves. But we know that when a P waves travels, so when a P wave travels, so it is traveling through different mediums, means different densities. So in different densities, the velocity of the P wave, what do we know? Velocity of the P wave is differing. So it is differs. So velocity differs. This is what we know in a overall, that velocity of the so-called P waves is differed. And next, so let us understand that refractions. So P waves has a property of refractions when there is a change in the medium. So now let me explain you the understanding what is refractions. Let me tell you students one thing. This is a medium. So this part is a medium and this is a another medium, which means this is a rarer medium, this is a denser medium. So denser medium. So when a light or some not light, when a seismic waves, we are studying about seismic waves, so we can study about only seismic. When seismic wave passes, let me take a other ink. So when a seismic wave passes, so from one medium to other medium, it will not pass through a straight line. It will be deflected. so it is being deflected. So this deflection is called as refraction. So overall now you understand what is refractions. This is what properties of S and P waves. We had also already discussed everything about the properties of the P waves in detail. Now let me explain the shadow zone. So before understanding the shadow zone, you must understand this two images properly. This two images will completely teach you what is a shadow zone. See here, this spot. So this spot is considered as the epicenter, which means here if you are taking this is the surface of the earth, interior along the fault line, somewhere here we will get a focus, so earthquake. So straight perpendicular line above the focus is epicenter. So epicenter is located on the surface of the earth. So now along the epicenter and the surface of the earth, we will have a seismograph to note the seismic waves and also find the seismic waves. Now, so when the seismologist has tested, these S waves are to be not found beyond 103 degrees. So here from here they had studied that some S waves are not to be found beyond 103 degrees, which means obviously this indicates that there is a liquid particle present over here. So because S waves have a property that it will not travel beyond the so called whatever we say it as the liquid layer. So obviously this is sure that beyond 103 degrees there is no detection of the S waves. So above the 103 degrees this region is to be considered as the shadow zone of the S waves. So this is what this image taught you. Let me explain the next image. Here you can see clearly up to 103 degrees S waves are not found, but after that here you can see P waves are refracted, again refracted and again found beyond 104 degrees, which means from 103 degrees to 142 degrees, 142 degrees, between this angles there is no detection of P waves. This part is called as P wave shadow zone. So this is called as a P wave shadow zone. Okay, now we understood the concept. Okay, now you need to have an idea how this could be helping, how this shadow zone will really help us in understanding the seismology and earth interior, and also we will study why it is so very important. Yeah, now regarding a shadow zone we will have a data analysis, which is part of important for your prelims preparations, which means P waves. So P waves are shadowed along 103 degrees to 142 degrees. Students, there is a confusion between the students that so these values are differed in different books. So kindly stick to the one data that is from your so-called NCERT. So NCERT data is the most authenticated where you can trust because it is a government released data. So this is what we can trust. And next, S waves. So if you are considering S waves, so we will know that greater than 103 degrees is a shadow zone. So here shadow zone for the S waves. Now from this we know that S wave cannot pass through liquid. So S waves cannot pass through liquid, so that there is a presence of magma. So above 103 degrees there is no detection of so called S waves, which means there is a presence of liquid layer. So it is confirmed that we have a liquid layer beyond the so called S waves. This is how we will be able to detect the interior of the earth. So obviously this is what very important of defining what type of layer is present inside the earth. So guys, this is so very important in detecting the interior of the earth. Okay students, now let me take you to the historical background of the how this seismic waves has started and how it could be very useful and how it has been defined. Okay, now let me come to the historic background. So historical background means first of all we can understand why these seismic waves are really very important in your studies. Yes students, so here it is important to study the earth interior. So we know that earth has a different types of layers present inside it. So earth's interior consists of crust and mantle. So it's crust and mantle and core. This is what we know, but we need to know what type of layer is inside. So which means from the seismic waves, from the shadow zone study only, we will come to know that here crust and mantle, crust, mantle and inner core. So these are all the part of the interior of the earth that act as a solid. So this part is in solid form. And next, if you consider the outer core, so if you consider the outer core, which is a liquid in structure, so we know that outer core is a liquid in structure. And next, now I am explaining the, so this is possible just based on the seismic study of the shadow zone. Now we shall study the history, how this shadow zone has really evolved and who is the scientist or geologist behind it. Now let me show you Richard Oldham. So he is a person named Richard Oldham. Okay, Oldham. He is an geologist. So he is a great geologist of the time. So he is a geologist. So he who studies the earth and its structure and earth's interior is called as the geologist. So he has defined or discovered that in 1906 that the outer core is a liquid. How he found that outer core is a liquid? So he had realized that in seismograms. So in seismograms, which is used to detect the so-called, which is used to detect the so-called seismic waves. Through the seismograms, he had been clearly known that after 120 degrees, after 120 degrees, there is no any direct evidences of, there is no any direct evidences. So there is no any direct evidences of the S waves. So which means S waves are not found. So he knows that if S waves are not found, he know the quality and features of the S wave, which means it cannot pass through the liquid. So by this he has decided that there is a so-called outer core inside the earth which is liquid in structure. This is how Richard Oldham has detected that outer core is a liquid. And again you must understand the other scientist called as Benno Gutenberg. So Benno Gutenberg, when you are reading interior of the earth, this person is a very important. So why this Benno Gutenberg is important? See here, there is a discontinuities about the interior of the earth. It is a part of core and mantle. Between the core and mantle, the discontinuity is called as the Gutenberg discontinuity. In his name it has been named. Let us read it later. Okay, that is a separate topic which in future I will be clearly explaining you in the concept series of our videos. Here 1913 he had found that P waves. Already we know that Richard Oldman has said that S waves are not detected in that region, and also this Gutenberg has found that P waves there is a velocity changes. So velocity changes already when it travels through the core. So he had understood one thing. So if there is a velocity changes, so it means it is going through the refraction process, which means he had found that inner core. So inner core is a solid. So he had found that inner core is a solid, outer core is a liquid. Based on the S waves are not detected, P waves are slowing down. These are all the factors that had evidently provided that the interior of the earth is differentially, structurally liquid and solid. And next, you need to understand some Snell's law. So this is one law that had helped in understanding the so-called shadow zone. So Snell's law says that when a seismic waves, so here seismic waves when they travel, so when they travel, either they go through the process called a refraction. So it is either a refraction or a reflection. Refraction or a reflection is the process that they go through. This is what happened. So now from the above study we are clear and we are detailedly understanding one thing for sure. Wait, what is it? it is that shadow zone. So shadow zone is a zone, and by studying the shadow zone we are evidently finding that outer core, so outer core and inner core, we are able to differentiate between outer core and inner core, and the same way the shadow zones help in detecting the all interior regions of the so called earth, and this will help more in studying the seismology and earth's interior. Okay guys, I hope so you are clear in understanding the seismic waves. Once again I will say and show through the image. See here, after 103 degrees it is a shadow zone for S wave. See here, clearly watch the image over here. If see here, if there is a liquid layer present here, then obviously S wave will not travel through this region, so obviously they are reflected. So this is why this part is considered to be a liquid. So this part is considered to be liquid, and this is why this region is shadowed for the S wave. Similarly, if you are viewing this image also here, P waves, it is refracted. So if it is a solid layer it would have passed directly, but here there is a difference in the layer, so the so called waves, P waves, are refracted. If there is no inner solid it could have reached another form, but still there is a solid layer inside it, so that it is again deflected and finally come out and detected at the 142 degrees. So which means this itself shown that this part of the P waves is shadowed from 103 to 142 degrees. So this is obviously the phenomena that had taught us that outer core is liquid and inner core is solid. This is the only evidence that has been helped in studying the interior of the earth. Okay students, this is how we understand a topic in a detailed manner. If you like the video, kindly give a comment section, also give a positive comment, which means every comment of you will be noted. So with your positive comments and motivations, everything will help us in making more videos for your exam preparations and detailed analysis of every topic. Hope you would have liked the video. This is me, SPR, signing off. Have a nice day. Bye bye. Take care.